Introduction to vectors. As you know, vectors have two major components. One, magnitude, the other one is the direction. And to define direction, we take help of angles. So let's now understand how to show direction for a vector. So I've seen in different countries we have different nomenclature. So I'll try to cover most of it in this, right? So sometimes you may feel that, you are being taught in a different way. But remember that in different countries we have different nomenclatures, and let's appreciate that, right? So here we have measurement of angles, and the very first one is angle moving counterclockwise with respect to horizontal, right? So I hope you understand that's the most common. In trigonometry, we just use those as positive angles, correct? So we'll start from there. So let me draw a line showing our vector. So that is, let's say, our vector, okay? Now, this vector, let's say it makes an angle of, I'm writing from west here. Okay, so let me write in different ways. So let's say this is my x-axis and this is my y-axis for the time being. And let this angle here be 40 degrees, right? So let it be 40 degrees. I'm purposely not taking 45 because then you don't know whether I've subtracted it from that side or this side. So 40 is a good place to start with. Now if I'm given this angle, and let's say this is my geometric representation of the vector with tail at the origin and head right there, then how do I define its direction in vectors? Well, the most common and a way to do it is measure the angle from x-axis, positive x-axis, and go counterclockwise, right? So if I have to go counterclockwise from x-axis, then how much will that angle be? This is what I'm trying to say. So that is my positive x-axis, and I move counterclockwise. Now since it is 40 degrees from here, and we know a line makes 180 degrees, so it should be 180 minus 40. So that means this angle becomes 140 degrees. So this counterclockwise angle from x is always treated positive, and that's one way of referring to the angles in vectors. And it is the default way of referring angles in trigonometry, right? So counterclockwise from x is the positive angle. We also call it sometimes principal angle, right? So we'll write that, and this is angle moving counterclockwise with respect to horizontal. So that is one of the standards. The other standard which I've seen most of the time is to measure the angle from north, right? So let's have here another coordinate system. Normally in navigation, so whenever you're talking about direction of planes and ships, then we talk about true bearing angle. So you have come across this word true bearing angle or azimuth bearing. And if nothing is there as a qualifier for bearing, we just write bearing, then it means from north, right? So in all those cases, this angle, which we may call true bearing or azimuth bearing or just bearing, right, by default, is angle measured from north, right? This is like you do when using a compass, right? So that is the angle which compass will give you, and that's the most common angle used. So in vectors, normally by default we use bearing angle, right? Now let me first show what it is. Now if I am looking into the previous example, I'll make a new one later, then what is, do you think, the bearing angle? So what I'm trying to say is, what is the angle if I measure it from north? So it'd be like going all the way like this, right? So it is 270 plus 40 or 360 minus 50, right? So that is what it is. Now I'll make another one here, and let's say this time in this quadrant. Now, let's say this makes from minus x-axis as 30 degrees. Now, what is the true bearing angle for this? Let's try to measure that. The true bearing angle for this is when you measure from north, right? Let's do it. So from north, this angle should be that much, which is, you can say 270 minus 30 or 180 plus 60, either way, right? So we can write this as 270 minus 30 as 240 degrees. Correct? So that is, excuse me. So this is 240 degrees as true bearing angle, right? This is what a compass will show you, right? Now, important thing here is that you have to always mention this angle in 3 places. And in case we have an angle in quadrant 1, you know it is going to be less than 90, so it will be in 2 places, right? In that case, you have to put 0 and then that angle, right? And north, we write north as 0, 0, 0 degrees. That's how we write north in bearing angles. And east, this is x becomes east, right? When you look at the compass, this will be written as 0, 90 degrees. And this is 180 degrees. And that is 270 degrees. So these are true bearing angles or the bearing angles, right? And always, as you've seen here, they will be given in 3 places, measured in degrees from north clockwise. Correct? So I've made a note here which summarizes all this. Now, let's look into another bearing angle, and we call that quadrant bearing. So, if we write quadrant bearing, then what does it mean? It basically means that we are trying to write our angle from 0 to 90 degrees, right? Not in 3 places. And we are measuring this angle with reference to north-south line. Okay, so we will measure this angle with reference to north-south line. And we will see how much off we are from north-south line. And the direction is whether east or west. So that is how we see it. For example, if this angle I have to write in quadrant bearing angle, then we can see that from south we are off 60 degrees, total is 90, right? Towards west, correct? So in quadrant bearing angle, I will write this as from south. So, so I'll write this as, let me write here on this side, from south 60 degrees west, and it is read as 60 degrees of west from south. Do you see that? That is how it is written, right? So it is written, oh sorry, okay, let me say it again. When we write this as this, it should be read as 60 degrees west of south. Do you understand? 60 degrees west of south, right? So quadrant angles are actually given in 3 parts. So we have 3 parts to this. So 1, 2 and 3, where this shows it is off from which line, north or south. So basically it has to be off north-south line, but it could be either north or south. Is that okay? Now this is given for degrees, and that degree is in 2 places, like 60 degrees between 0 to 90 degrees, okay? So that is degrees, right? And this is off in which direction it is. So that gives in which directions. That gives actually in which direction. Is that okay? So let me make one angle for you and then we will discuss it, right? So let's say this is the angle this time, and let me say that this angle here is actually, from here it is 20 degrees. Let us say it is 20 degrees. Now how will I write this angle as a quadrant bearing angle? So we can see from north-south line how much off it is. towards east. So that is 90 minus 20, it gives me 70 degrees. Is that okay? So we will write it like this here. We'll write this south, right? Let me write this south. So here it is south and 70 degrees towards east, right? So that is how we are going to write the angle. And how are we going to read it? We will read it as 70 degrees east of south. Do you understand? 70 degrees east of south. So that is how we are going to read it. So that is called quadrant bearing angle, right? So at times, so these are common ways of referring to the angle in vectors, but I have seen in books they sometimes write angle even of east and west, right? So sometimes they will mention this as, so instead of being strictly following quadrant bearing, they may write this as 20 degrees of east, right? So they may refer it to some other ways. So I may write this as, which I do not recommend, but let me write this. It could be from east, right? So I could write this as east, and from east 20 degrees towards south. Do you understand? So that you may find in some books, and that means 20 degrees south of east. Do you understand? 20 degrees south of east. It makes sense. It's not wrong, correct? So 20 degrees south of east, but that is not a quadrant bearing angle. Mention. That's very important. If I write this and if I say, is it a quadrant bearing angle? The answer is no, right? But yes, it is a way of referring to an angle. It is not wrong, right? It is 20 degrees south, 20 degrees south of east. Do you see that? That's how you read it. And if I say 20 degrees south of east, you know what I mean, right? So in that fashion, this could be 30 degrees south of west, right? So they don't really stick to north-south line. So at times, with convenience, we do write angles with east-west line also, and that is not wrong. Quite a few books follow it, right? But when we write quadrant bearing or true bearing, then we are always measuring in true bearing from north. In quadrant bearing, it is north-south line, right? So it could be of north or south, correct? That is how it is. Now, as a part of exercise, what you can do is, all the angles which I have written on this page, you can write them in 3 different ways, right? Any 3 ways you like. I prefer these 3 which are there on my page. So angle counterclockwise from positive x-axis is one way of writing, right? That is the principal angle. And true bearing angle is the angle clockwise from north. And quadrant bearing angle is the angle between 0 to 90 degrees of north-south line. And we have to mention in which direction, whether it's towards east or towards west. So that is how we will be giving direction to our vectors in the following chapters. It's very important for you to understand, and I have few questions to follow. Thanks and all the best.